Hello students, as in the last lecture, we saw whenever the power of I it is greater than 20, 30, or if the power it is in 100 or in thousands, how to find the answer by using some different method. Okay, so as I told, there are 3 4 different methods in which you can find your answer. Okay, so in the last lecture I had explained one easiest method in which you can find your answer by using one formula, that is dividend equal to divisor into quotient plus remainder. And as I told, for each and every number the divisor will be same, whether it is 35, 888, 403, the divisor you will take fixed, the divisor will be 4. So with respect to 4 you have to divide each and every number, as this all things I had explained in the last video lecture. So let's take some few examples from the exercise. Okay, as here the first one is what, evaluate the following, and the first one which we have to find it is I raised to 35. So I raised to 35. Okay, so we'll divide and see. 35. So as I told, you have to divide, always you have to divide the number by 4. So you have to consider the divisor 4 only. Okay, so 4 8 side is what, 32, yes or no? So you will be left with what, 3. Okay, don't solve this sum further, keep as it is. So here we got the remainder as 3. So using the formula, which one, that is dividend equal to divisor into quotient plus remainder. So dividend is what here, 35, divisor is what, 4, quotient which we got it is 8, and remainder is what, 3. So we can break this 35 as what, I raised to 4 into 8 plus 3, yes or no? 4 into 8 plus 3. Further, after this 4 raised, I raised to 4 into 8 plus 3, this can be written as what, I raised to 4 into 8 into I raised to 3. How? As we know that a raised to m into n, m plus n, sorry, m plus n, we can write as what, a raised to m into a raised to n, or else we know that a raised to m into a raised to n, we can write as what, a raised to m plus n. Okay, so if here we have, we'll consider this part as m and this part as n. So if plus is there, so we can break it as a raised to m into a raised to n, or as vice versa. Okay, now after this, can I write this as 4 inside and 8 outside the bracket? Yes or no? 4 inside and 8 outside the bracket, into will keep this I cube as it is. So what I did, using the relation, that is formula, which one, a raised to m into n, we can write as a raised to m the whole raised to n, or else a raised to m the whole raised to n, it can be written as a raised to m into n, yes or no? So using the basic formulas of indices, we can able to find our answer. So here we know that I raised to 4, I raised to 4 is what, 1, and I cube is what, minus I. So in place of I raised to 4 we can write as 1. So that's why I told, always divide the number with respect to 4, so that what will happen, in second last step you will get I raised to 4, in place of I raised to 4 you can write 1, and we know that 1 raised to any power is 1 only. So here 1 raised to 8 into I cube is what, minus I. So 1 raised to 8 is what, 1 into minus I. So here the final answer is what, minus 1 into minus I is minus I. So here we got the answer for I raised to 35 as minus I. So in this way you have to find your answer. Okay, so let's take some few more example. As the second one, we know that it is what, I raised to I raised to 888. So when you will divide this number by 4, So 222 into 4, you will get what? 888. So the remainder will be 0. So here this 888 we can write as what? Okay, by using this formula, dividend is what? 888. Divisor is what? 4. Into quotient, here we got it is 222, and the remainder is what? 0. So this 888 we can write as what? 4 into 222 plus 0. Okay, further consider this as m and this as n, so this we can write as I raised to 4 into 222, yes or no, into I raised to 0. Okay, a raised to m plus n we can write as a raised to m into a raised to n. Okay, after this we can write as 4 inside and 222 outside the bracket, yes or no, using the formula a raised to m into n, which we can write as a raised to m the whole raised to n. Okay, as we know that I raised to 4 is what? 1. So 1 raised to any power, it will be what? 1. And I raised to 0, I raised to 0 is what? 1, because we know that any number raised to 0 is what? 1. So 1 raised to any power will be 1. So 1 into 1 will be what? 1. So here we got the answer for I raised to 888. So in this way you can find your answer by using this method. Okay, so simply what you have to do, you have to divide this power by 4, and after dividing you have to break this section by using this formula, dividend equal to divisor into quotient plus a remainder. Okay, and after that rest, using the basic indices formula, you can able to find your answer. Okay, so please try the next question number 3rd, 4th and 5th by yourself. Okay, so now we'll see the next one. So here the next one, it is what? Here we have I raised to 30, I raised to 40, I raised to 50 and I raised to 60. As here we saw, here we have to find the individual values. Here we have combined value like I raised to 30, I raised to 40, I raised to 50 and 60. We have to find the answer for all this section. Okay, so for this also there are 2-3 different method. The one simplest method is what? Find I30 separately, I40 separately, I50 and then I60. Okay, so we'll find first I30. Okay, so 4 sevens are 28, yes or no? So you'll be left with what? 2. Then next 4 tens are 40, so you'll be left with what? 0. The next is what? 50. Always we have to divide it by 4. Okay, 4 ones are 4, so you'll be left with 1 0. 4 twos are 8, so remainder is 2. And the last one is what? 60. 4 ones are 4, so you'll be left with 2. 24 fives are 20. Okay, so now we can break this 30 as what? I raised to 4 into 7 plus 2, yes or no? Using the formula dividend equal to divisor into quotient plus remainder. So this is the dividend divisor into quotient plus remainder. Further, this we can write as what? I raised to 4 into 7 into I square, yes or no? And this we can write as I raised to 4 the whole raised to 7 into I square. I raised to 4 we know that it is 1, and I square is what? Minus 1. So I raised to 7, 1 raised to any power is 1 into minus 1. So here we got the answer, that is minus 1 for I30. Okay, so here we got the I30 as minus 1. So now we'll see for I raised to 40. So this I raised to 40, we can break this 40 as 4 into 10 plus 0. dividend equal to divisor into quotient plus remainder. So further this can be written as what, I raised to 4 into 10 into I raised to 0. This can be written as I raised to 4 the whole raised to 10 into I raised to 0. So I raised to 4 is what, 1 raised to 10, and any number raised to 0 is what, 1. So 1 raised to 10 is 1. 1 into 1 is what, 1. So here we got the second answer for I raised to 40. Similarly, we'll find I50 and I60. So I50 we can write as I raised to 4 into 12 plus 2. So 4 2 z is 4 12 z is 48. 48 plus 2 is 50. Yes or no? So this we can write as what, I raised to 4 into 12 into I raised to 2. I raised to 4 the whole raised to 12 into I square. I raised to 4 is what, 1 the whole raised to 12 into I square. 1 raised to 12 is what, 1. I square is what, minus 1. So 1 into minus 1 is what, minus 1. So here we got the answer for I raised to 50 also. Okay. Now with the last one, that is I raised to 60. So I raised to 60 we can write as what, 4 into 15 plus 0. So this we can write as I raised to 4 into 15 into I raised to 0. So further this we can write as I raised to 4 the whole raised to 15 into I raised to 0. I raised to 4 is 1 raised to 15, and any number raised to 0 is 1. 1 raised to 15 is 1 into 1. So here we got the answer for I raised to 60 also. Now in the question it says that we have to find the answer for I raised to 30, I raised to 40, I raised to 50, I raised to 60. Okay, so first you find all the values separately, I30, I40, I50, I60, and then simply substitute the value. I30 is what, minus 1. I40 is what, 1. I50 is what, minus 1. I60 is what, 1. Yes or no? So here clearly we can see that, yep, minus 1 and plus 1 will get cancelled, minus 1 1 plus 1 will get cancelled, and we will get what, a 0. Okay, we know that same symbol, same number with the opposite symbol, it will get cancelled. Okay, so yeah, minus 1 plus 1 0, minus 1 plus 1 0. So yeah, we left with 0. So for this answer, for the question number 6, the answer is what, 0. Okay, I hope you all understood the sum. So whenever individual values are there, simply solve the sums. Whenever it is combined, see to that, find the all the answers separately, then take the question, substitute the value, you will get the answer. Okay, so in this way you have to present your sums. Okay, so see to that, question number 3, 4 and 5, solve it by yourself. Okay, please try these three sums by yourself. Okay, so let's move on to some more sums from the exercise. Okay, here in this question it says that you have to show that 1 plus I raised to 10 plus I raised to 20 plus I raised to 30 is a real number. So what do you mean by real number? So real number means the final answer, it should be without I. That means the final answer, it should contain number like 2, 3, 4. It should be without I. So the answer, if it is without I, so we can say that it is a real number. So let's move on. So first, 1 plus I raised to 10 plus I raised to 20 plus I raised to 30 equals to, first we'll find the answer for all the section. Okay, first we'll find I raised to 10, then I raised to 20, and then I raised to 30 as we did in the previous sum. Okay, find the answer separately and then substitute the value. Okay, so I raised to 10, so divided by 4, so 4 2s are 8, so here we left with what, 2. So this we can write as I raised to 4 into 2 plus 2. So further this we can write as I raised to 4 into 2 into I square using the formula a raised to m plus n. Yes or no? So further this we can write as I raised to 4 the whole square into I square. Yes or no? I raised to 4 is what? 1 the whole square into I square, we know that it is minus 1. 1 square is 1 into minus 1. So 1 into minus 1 is minus 1. So here we got the answer for I raised to 10. Yes or no? So let's see for 20. So 24 5s are 20. So this we can write as what? I raised to 4 into 5 plus 0. So I raised to 4 into 5 into I raised to 0. So further this we can write as I raised to 4 the whole raised to 5 into I raised to 0. I raised to 4 we know that it is 1. 1 raised to 5 into I raised to 0 is what? 1. 1 raised to 5 it is 1. So the final answer will be what? 1. So we got the answer for I raised to 20. I hope you all understood how to find the answer whenever the power it is 10, 20, 30, 40 using this method. Or for 10, 20, 30 we have one trick also, directly we can able to find. Okay, yes or no? So what is the trick? 1 minus 1 I minus I. Yes or no? Okay, so this is 1 2 3 4. Okay, so these are the what? Powers. Okay, with the help of this also we can able to find our answer. But see to it that this method, this technique, it is only for whenever we have the power it is less than 20 30. But whenever the power it is more than 20 30, like 100, when it is in 1000, so that time this will take a time, this technique will take a time. Yes or no? So this will be the perfect method whenever the values are bigger. And see to it that we'll keep this method fixed. Whether we have to find the value for I raised to 10 20 30 40, we'll keep this method fixed. Simply what you have to do, whenever the power it is 10 20 30, any power, simply divide it by 4 and use the relation dividend equal to divisor into quotient plus remainder. You will get your answer easily. Okay, in simple language I will say that. So I raised to 30, I raised to 30, 4 sevens are 28. So here we left with 2. So I raised to 4 into 7 plus 2. So I raised to 4 into 7 into I square. I raised to 4 the whole raised to 7 into I square. I raised to 4 is what? 1 raised to 7 into I square is what? Minus 1. 1 raised to 7 is 1 into minus 1. So here we got minus 1. So simply you have to substitute the value now. I raised to 10 is what? Here we got minus 1. I raised to 20 it is 1. I raised to 30, I raised to 30 here we got minus 1. Again same, plus 1 minus 1 will get cancelled. So here we got the answer as 0. So for this sum also the answer is what? 0. So simply first you will find the answer separately, take the question, substitute the value, you will get the answer. So these are the fair step. Okay, this is not the rough work. So this you will show in the exam. This part and this part, then you will write the question, substitute the value, then you will get the answer. Okay, so these are the steps which you have to include in your sums. Okay, that is not the rough work. So let's move on to the some more sums from the exercise. The next one is what we have to find the values of I raised to 49, I raised to 68, I raised to 89, I raised to 110. Okay, as just now only we saw many sums based on this type, as we have to find the individual value for I raised to the any power. Okay, so please try these two sums by yourself. Simply we will take first I raised to 49, break using the relation of dividend equal to divisor into quotient plus remainder. Find the answer for I raised to 49 as we did here in the previous sum. As I took I raised to 10 separately, I 20 separately, I 30 separately. So here you will take I raised to 49, I raised to 68, I raised to 89, I raised to 110. Write the question, substitute the value, you will get the answer. So I feel that you can try this sums by yourself. So take these two sums also as homework. Okay, so please try this two sums by using the same method. Okay, so always see to it that power whether the power is 30 20 40 60 80 100, any power, always divide the number by 4. So take the divisor as 4 only. Okay, I hope these two sums you can try by yourself. So let's see some few examples from the exercise only. These are the sums from the exercise only. Okay, so I guess this was the similar sum, so I said to solve this sum by yourself. So let's move on to the next one. Okay, so let's move on to the next one. So here we have one question which is very interesting. As you will see that the power, it is more than 500. Okay, it is in 100 only. So 592, 590, 588. So if you do this sum like this, if you take this I raised to 592 separately, I raised to 590 separately, I raised to 588 separately, okay, it will take a too much time. Of course, you will break this number, you will divide 592 by 4, then you will apply the formula dividend equal to divisor into quotient plus remainder, then after that you will get the answer for 592. The same way it will goes for 590, 588, 586, 584. Yes or no? So it will take too much time to solve this sum. Okay, sir, is there we have any other method for this sum? Yes, there are two three different method for this sum also. One easiest method is what we'll see now here. Just focus on this corresponding element. Okay, 590 to 582. So can I say 590 to 582, there is a difference of 10 numbers. 590, 580, again there is a difference of 10 numbers. 588, 578, again there is a difference of 10 numbers. 586, 576, difference of 10. 584, 574, difference of 10. Okay, so now as we have to find the answer for this, so here we'll write equal to. The technique is very simple. Okay, instead of finding this individual values, there is one simplest method is what, as just now we saw there is a difference of 10 numbers. So what I will do, I will remove I raised to 10, I raised to 10 common from the numerator. So as I remove 10, 10, 10, 10 from each section. So as we remove 10 from this part, so here you will left with what? Here you will get 582. Yes or no? Plus 10 numbers, it is outside the bracket. So here you will get I raised to 580. 10 numbers, it is common. So as clearly we can see that 10, 10, 10 we can remove common. Okay, it is not common actually. We are here we saw the difference, it was 10. So what I did to make the sum easy to find the answer just in just fraction of second, what I did, I saw the difference of 10, 10. So what I decided to remove 10 I raised to 10 from each section. So I had removed I raised to 10 from each part. So here you will get I raised to 582, 580, 578, I raised to 576, I raised to 574. So in the denominator you will get what? I raised to 582, I raised to 580, I raised to 578, I raised to 576, I raised to 574. We can check whether the answer it is right or wrong. As when you will bracket open with this I raised to 10 into I raised to 582, using the formula a raised to m into a raised to n, which is a raised to m plus n. So this can be written as I raised to 10 plus 582. So further this we can write as what? I raised to 10 plus 582 will be what? 592. Yes, this 592 we can break it as 10 and 582. Okay, so when you will multiply this two section you will get 590. When you will multiply this two section you will get 588. How? But how? By using this relation, by using this formula, a raised to m into a raised to n. Bracket open and check, you will get the previous step. I hope you all understood till here. What I did, I saw the difference in the corresponding element. So I decided to remove I raised to 10 from the numerator. After that, as clearly we can see that after removing I raised to 10, as clearly we can see that this section and this part look same. So we can cancel this part. So you will be left with I raised to 10. Okay, so we know that I raised to 10, there are 3 4 different method. You can break this 10 as 7 into 3, 8 into 2. Yes or no? Or by using this technique also you can able to find your answer. Yes or no? 1 2 3 4 5 6 7 8 9 10. So answer will be what? Minus 1. So directly we can write the answer as minus 1. Yes or no? Or else we can break this 10 with respect to 4. So divisor will take this as 4. So 4 twos are 8. So we'll solve this sum by using this method only. Okay, so now we'll stick with a proper one method, either by using this method or this method. So this method, it has a limit. Okay, whenever the power it is 20 30, so it will be easy, and it does not have any limit. Whether the power is 10 20 30 40 100 1000, we can apply this method to find our answer. So we'll fix this method whenever the power it is 10 20 30 40, any power. Okay, using the dividend equal to divisor into quotient plus remainder formula. Okay, so I raised to 10 we can write as what? So dividend equal to divisor into quotient plus remainder. So 10 we can write as what? 4 into 2 plus 2. So further this we can write as I raised to 4 into 2 into I square. Yes or no? I raised to 4 we can write as I raised to 4 the whole square into I square. We know that I raised to 4 is what? 1, and I square is what? Minus 1. Okay, so I raised to 4 is what? 1 the whole square into I square is minus 1. So 1 square is 1, minus 1. Yes or no? So 1 into minus 1 you will get what? Minus 1. So here we got the answer for this section, it is minus 1. So here by using this technique also we'll see whether we are getting the minus 1 or not. So this is 1 2 3 4 5 6 7 8 9 10. Yes, still we are getting the same answer. So or if you break this I raised to 10 as I raised to 8 into I square, yeah, I raised to 7 into I cube, or I raised to 4 into I raised to 6, break in any term, but the final answer it will be what? Minus 1 only. Okay, so in this way you can find your answer. As initially when we saw this sum, we felt that it will be very difficult sum, as the power it was more than 100. Okay, so what I did, once again I will explain. As here we saw there was a difference of 10 numbers in the corresponding element. Yes or no? So I decided to remove I raised to 10 common from the numerator. So here as I removed I raised to 10, here we saw this part and this part it was similar. And when you will bracket open and check using the formula of a raised to m into a raised to n, you will get this previous step. I raised to 10 into I raised to 582, use the relation, you will get I raised to 592. So from this we can come to the conclusion that we can remove I raised to 10 as common, because I raised to 10 is common. Okay, why I raised to 10 only? So why not I raised to 20? Why not I raised to 30? So that is a trick that only I had explained. Just see the difference of the corresponding element. If the difference of the corresponding element is 20, so you will remove I raised to 20 outside. If the difference between this corresponding element is 30, so you will take the common I raised to 30 from each and every term. Understood now? Okay, so here the corresponding element difference was 10, so I had taken I raised to 10 as common. So rest this will get cancelled, and after that we know that there are 3 4 different methods in which you can find your answer: by direct technique, also by using dividend equal to divisor into quotient plus remainder method, or by splitting. Also split this number, break this number. In all the three cases you will get the same answer. So now it is on you which method you have to apply. Okay, so see to that don't solve this sum like this: I raised to 592 separately, 5 I raised to 590, I raised to 588 separately. It will take too much time. So this was the technique, and technique is very simple. If the difference is 20, so you will take I raised to 20 as common. If the difference is 10, so you will take I raised to 10 as common. Okay, understood? So let's check some few more example. Let's see if there any change in the question, so that part I will explain. If it is similar sum, so that sum you have to tackle by yourself. Okay, let's move on to the next sums. So here the next sum is what? Show that 1 plus I raised to 10 I raised to 100 minus I raised to 1000 is equals to 0. So this sum also it is very simple. Just I will explain this part, and this sum also you have to try it by yourself. Okay, you will take the left hand side, that is 1 plus I raised to 10 plus I raised to 100 minus I raised to 1000. Solve this I raised to 10 separately, I raised to 100 separately, and I raised to 1000. Then after that simply substitute the value of I raised to 10, I raised to 100 and I raised to 1000. So after that what you will see, you must get a 0, because as in this question it is clearly mentioned you have to show that left hand side is equal to right hand side. Okay, so 0 when you will get, when each and every term it will get cancelled, so you will get what? 0, of course, yes or no? So here in simple language, first you will find I raised to 10 by using this technique, dividend equal to divisor into quotient plus remainder. I raised to 100, I raised to 1000. Take the left hand side, substitute the value. If it is equals to 0, then we can say left hand side equal to right hand side, and set is proved. As it is clearly mentioned, show that means this left hand side answer, it has to be 0 only, because here it is mentioned show that, it is not check whether it is equal or not. It is mentioned that show that the left hand side answer, it should be equal to 0. So as you will substitute the value of I raised to 10, 100 and 1000, of course this part left hand side it will be equal to 0, and hence it is proved. So please try this sum by yourself, and even the second sum also. 1 plus I raised to 14, I raised to 18, I raised to 22 is a real number. Just now only we saw is a real, is a real, that is a question mark. Here we have to check whether this part is a real or a imaginary. After solving only you will come to know. Now listen here. You will solve I raised to 14 separately, I raised to 18, I raised to 22 by using this method. If suppose after substituting the value of I raised to 14, 18 and 22, if you are getting the answer in numbers like 3, 4, 5 without I, that means it is a real number. If you are getting the answer with I, you will see that it is not a real number. Real number means what? In simple language, number without I is a real number. Number with I, it is not a real number. Okay, I guess these two sums you can try it by yourself, and the remaining part we'll see in the next lecture. I hope you all understood all the sums which we had did in this lecture. Okay, so the remaining section we'll see in the next part, and this sum was little interesting and was very easy also. Okay, so please don't skip this sum, as this sum is very important for exam point of view. So till then, goodbye, see you in next lecture.